Alright, in this video we're going to look at three different forms of solving for x. We're going to factor, we're going to complete the square, and then we're going to take the square root. Let's go ahead and do that one real quick. So over here, notice we have a quantity squared, and then on the other side we have a constant. So this happens to be a perfect square that makes it nice, but it doesn't have to be. So if I take the square root of both sides, the thing to keep in mind when you're square rooting both sides is that squaring, this original squaring, can lead to our positive solution in two ways. We could have two positives, or we could have two negatives multiplying together to give us a positive. So we counteract that by keeping in mind that this equals the positive and negative version of the square root. So from here, it may be helpful initially to write this as two things. We have x minus 2 equals 4, and we have x minus 2 equals negative 4. Okay. Now as we do that, we can now solve these pretty simply by adding 2 to both sides, getting 6, adding 2 to both sides, and getting negative 2. So then we just need to make sure that those solutions work. 6 minus 2 is 4, negative 2 minus 2 is negative 4, and then both those squarings work. Alright, let's move to this side. It's going to be a good candidate for possibly factoring. Excuse me. The first thing I want to do is I'm going to divide by 3, because that works out easily in this case. So now I have, remember when I'm dividing, each term gets divided, so 3 divided by 3 is 1, so I have x squared. 18 divided by 3 is 6. And then in this case, 48 divided by 3 is 16. Okay. Now, to try to factor, I'm going to move everything to one side, so I'm going to subtract by 16 on each side. Now, since these are not like terms, they don't get combined in any way. So that's why I have that situation, and then I picked 16 so that I would have 0 on this side. Now, because we have this negative here, that means when I have a quadratic trinomial here, if it's going to factor, remember I'm looking for two solutions. I know these are both x's because that's what gives me the x squared. Since this is negative, I know I have to have a negative and a positive. So that's the only way that these terms can multiply. These terms have to be constants because I have a constant here. So I'm looking for something that gives me a difference of 6 out of the factors that multiply together to get 16. So I have 16 and 1, I have 8 and 2, and I have 4 and 4. So 8 and 2 must be it. This is positive, so I have a positive 8 and a negative 2. So now, because this times this equals 0, to make that happen, one of these would have to be 0. So if x minus 2 is equal to 0, then that means x is equal to 2. And if x plus 8 is equal to 0, then x must be negative 8. Alright. Now for the middle, we're going to complete the square. Now the first thing I want to do, there are two first steps that I could take. It doesn't matter the order. One of them is to simplify our leading coefficient. So we'll divide by 2. The other is to move our constant term to the other side. So if I divide by 2, I still have 0 on my right side, but now I have x squared plus 2x minus 1/2. That equals 0. Now I'm going to add my 1/2 to both sides. Oops, that's a plus. And add 1/2 to both sides. So now I have x squared plus 2x. I'm going to leave some space there. And then here I have my 1/2. Now what I want to do is find something here that allows me to make a square. So if you think about this, I have an x squared term, and I have two x terms. So it's length x by length 1, length x by length 1. And I want to try to make this into a square. Well, if I attach one of these to this side, and one of these to this side, now I have a length of x plus 1. This was length x, this was length 1. This is also an x plus 1. But I have this missing piece here. And in that case, my missing piece would be a 1 by 1 square. So that means if I add 1 here, then I can complete my square. So I have to add 1 here. So now that I've done that, this tells me that I can also rewrite that as x plus 1 times x plus 1. That's x plus 1 here by x plus 1 here. So I'm going to write that as x plus 1 quantity squared. And then that's equal to my 1/2 plus 1. I'm going to call that 3/2 here. Okay. So now I can use this method over here. It says I take the square root of both sides. So I get x plus 1 on that side. And remember, I have the positive and negative square roots of this side. So in my final step, if I subtract 1, then I find that x equals -1 plus or minus square root of 3/2. So that gives me two solutions for that equation, and that's what I would be looking for.